Hey everyone, just like we talked about in class, we're going to be flipping the class for Chapter 10, which is going to be all about area. So today is the first video for Chapter 10, and we're going to be talking about Section 10.1, which really just has to deal with basic area formulas and how we use them. So the first part of this, we're just going to go through a bunch of figures and make sure we get these area formulas down, and then we'll do some practice with actually using them. So our first figure is a parallelogram. Okay, so the area of a parallelogram with base B and height H is area equals base times height. So all we need to do is multiply the base and the height together. Now, an important note here is the height of a parallelogram is always measured along a segment that is perpendicular to a line containing the base. So in our example here, here's our base, and we know this is the height because it's perpendicular to that base. Now, something that you might see in some other problems, what we could do is we could actually extend this base outside of the figure and drop a perpendicular down out here. And that could be the height as well. This distance would still be the base, but that's why it says perpendicular to a line containing the base. We could actually extend that base and draw the height outside of that figure. And like I said, we'll get to problems like that in a little bit. Next one is a triangle. You guys are hopefully familiar with this already. Area of a triangle with base B and height H is area equals 1/2 base times height. And again here, the key with the height is it has to be the segment that's perpendicular to the base. The next one is likely new to all of us. So it's the area of a triangle, but now it's if I know two sides and an included angle. So the area of a triangle with sides A and B and included angle C. Remember, included angle means the angle is between the sides. So I have to have two sides and the angle in between them. If I have that, then I know my area is 1/2 AB sine C. So that'd be using some trig on our calculator. Okay, next we have a trapezoid. So the area of a trapezoid. Now with a trapezoid we have two bases. So the area of a trapezoid with bases B1 and B2 and height H is area equals, now here's how I like to write it. I like to write it H over 2. So I'm dividing that H by 2, and then I'm adding B1 plus B2. Again, every time we see that height, it's always going to be perpendicular to those bases. If it's not perpendicular, then we don't have a height. Okay, next is our rhombus. So the area of a rhombus with, now this area depends on the diagonals. So the area of a rhombus with diagonals D1 and D2 is A equals 1/2 D1 D2. So the thing there to notice is that we're multiplying the length of those diagonals. Now when we see D1 and D2, that's the length of the whole diagonal. So this whole diagonal in purple is D1, and the whole diagonal in blue is D2. It doesn't show that very well in the picture, but we want to make sure we're taking the product of the whole diagonal. Okay, next, area of a kite. This also depends on the diagonals. So with diagonals, D1 and D2, and we actually have the same formula here. So area equals 1/2 D1 D2. And again, that refers to the whole diagonal. The whole diagonal D1 times the whole diagonal D2, and we divide that product by 2. So the last formula then we have is the area of a circle. I'm guessing we all know this one already as well. Area of circle with radius R is A equals pi R squared. Okay, so those are all the shapes that we'll be working with throughout this chapter. So for the rest of the video, we're just going to go through some examples. Some are very straightforward, and some we have to be a little bit careful about what information we use to solve the problem. So I'm going to move over to page 3 here. Okay, we've got 2 goals for today. The first is just to be able to find the area of triangles, quadrilaterals, and circles if we're given all the dimensions. So just using the basic area formulas. The second one is actually being able to solve for dimension of the figure if I know the area. So I think of this as working backwards. Okay, so let's go over some basics. Now, obviously the most important thing here is to be able to recognize the figure. So I'm always going to kind of mention that first, then we'll pull the formula, and then it's just a matter of plugging in. So obviously in this first example, I think we all recognize that as a triangle. So I know the area of my triangle is 1/2 base times height. So looking at the picture, I have 1/2. My base is 6 here at the bottom, and my height, that perpendicular height, is 4.5. So now that's just a matter of putting it into my calculator. 0.5 times 6 times 4.5, and I get 13.5. Now, since units are specified in the problem, I'm going to make sure when I put my area to specify those as well. And again, since it's area, it's really yards times yards. We need for area to have square units, so yards squared. So I'm going to make a note of that and say, for area, we need to use square units. Okay, so now, number 2. Here we have a trapezoid. Okay, so I know the area of the trapezoid is h over 2 times base 1 plus base 2. So something important to remember here is that in a trapezoid, B1 and B2 are the parallel sides. So we make sure we plug in the right numbers in the right places. So B1 and B2 are the parallel sides. So as I'm looking at my example, we said, well, the height had to be that perpendicular distance between the 2 bases. So this is perpendicular, so I know my height is 5. So I have 5 over 2. And then the lengths of my parallel sides, I have 5.5 plus 11.3. And again, then we just go to our calculator to get that answer. So I'm going to use my fraction key to do 5 over 2. Then I have 5.5 plus 11.3. Whoops. And I get an area of 42. And let's see, our units were centimeters. So 42 square centimeters. Okay, and the next one, number 3. Now, this is our parallelogram. So I know the area of a parallelogram, we just said, was our base times height. Now, here's when I have to be a little bit careful of. We said the height was going to be that perpendicular distance. So if I look, here's my height right here. That's the only perpendicular distance I have. And then we said the height was going to be perpendicular to that segment containing the base. Now here's where we have to be careful. This is our parallelogram right here. So this is an extension of that base, but my actual base is 8 feet. This is just some extra information that we actually don't need to use in this problem. So now my base is 8, my height is 4, so I have 32 square feet. Okay. Now, number 4, here we have a triangle. But we can't use our 1/2 base times height because I actually don't have any perpendicular height for this triangle. So here's where we're going to use our formula for the triangle with 2 sides and an included angle. Okay, and so I know that formula is area equals 1/2 AB times the sine of C. Again, we know that the angle always goes with sine, so that C is always going to be the angle. So I have 1/2, one side is 8, one side is 5. It doesn't matter which one you call A or B. And then I'm going to take the sine of 87 because that's my angle. Let's see. Now it told us to round to the nearest tenth, so when we do that, we'll just need to keep that in mind. So 0.5 times 8 times 5 times the sine of 87 to the nearest tenth. Well, this is going to round up actually to 0, so I'm going to have 20.0, and we're going to have square meters. All right, next couple are very straightforward. Here we have our circle with radius 5. I know the area of a circle is pi r squared. So I have pi, my radius here is 5 squared. So I know my answer is going to be 25 pi, or if I plug this into my calculator, let's see, I have pi times 5 squared. It's going to give me exact, so I'm going to use that little arrow key, and I get 78.5 square inches. Okay, next one is a kite. I can tell because I have two pairs of consecutive sides that are congruent. So we said it's the area is 1/2 d1 times d2. And now we have to remember d1 and d2, I'm going to make a note, d1 and d2 are the lengths of the whole diagonal. So remember I have to add up the whole part. So again, it doesn't matter what I call D1 and what I call D2. So D1, I'm going to call this diagonal. So I have to be careful, 30 and 30, that diagonal is 60. And then for D2, I'm going to add 25 and 75 to get 100. So if I multiply those, I'm going to get, let's see, 30 times 100, so 3,000, and that's going to be square centimeters. Okay, so again, that was just using basic area formulas with some basic shapes. So let's keep going on to page 4. Okay, so here we're going to do a few where there's just a few small twists, and then we're going to look at some where we work backwards. Okay, so we're still finding the area and rounding to the 10th if necessary. So here I know that I have a trapezoid. I have two parallel sides. Trapezoid I know is h over 2 times b1 plus b2. Now remember, we said that height is the perpendicular distance between the bases. So I'm looking for some perpendicular distance. And I see I have this perpendicular. It happens to be one of the legs of the trapezoid, which is okay. So my height is 5 over 2. And again, my bases are the parallel sides. So I only need to be concerned with these two sides. This, again, is just some extra information that's been thrown in there. So B1 I'm going to call 4.5. B2 I'm going to call 9.9. And then again, we just go back to our calculator. I'm going to clear some of this other stuff off. So I'm going to use N over D. So I have 5 over 2 times 4.5 plus 9.9. And I get 36. And we have square miles, a rather big trapezoid. Okay, next figure, again, is our parallelogram. So its area equals base times height. And again, it's just discerning what information we need. Now, if we remember about parallelograms here, we know opposite sides are congruent. So it's clear here that my perpendicular distance, my height, is 3 inches. Now, we said that height had to be perpendicular to the base. Well, if this side is 4.8, this side is 4.8 as well. So now I have my base and my height. And again, this is just some extra information. We don't use that because it's not the base and it's not a perpendicular distance. So our base is 4.8 times our height of 3. So that's going to give us 14.4, and the units are going to be square inches. Okay, I think the next two we'll just talk about in class for a quick warm-up. There's not really too much to these last two problems, 9 and 10. Let's do a couple where we work backwards, and then that'll finish us up for today. So now, for number 11, now they're going to give us the area, and we have to solve for one of the dimensions. So in this case, it says to find the base of a parallelogram. So that's the first thing I'm looking out for. I know the area of a parallelogram is just base times height. Now, it's telling me that H is 56, and my area is 28. So I have 28 equals, I don't know what B is, and I know my H is 56. So now I'm going to divide both sides by 56 so I can get B by itself. And if I do that, whoops, I wrote 5, looks like 5B by 56. So I'm going to do 28 divided by 56, and I get 0.5 for the base. So B equals 0.5. Now, I don't have square units here because this is not an area, it's just one dimension of the figure. So B equals 0.5 yards. Okay, then last one for today is asking us to find the radius of a circle in which area is 144 pi inches squared. So again, here's my key. My figure is a circle. So now my area is pi r squared. Now, here's where I have to be very careful. It tells me A equals 144 pi. You need to make sure you take that pi with you, otherwise you're going to get an error. So I know that's equal to pi r squared. Well, the first thing I can do is divide both sides by pi. So I have 144 equals r squared. So r is going to be the square root of 144. Now, normally when we're solving, we take the positive or negative value, but obviously radius can't be negative, so we're only concerned with the positive. So now again, just use square root of 144 if that's not one you know readily. And we get our radius is 12 inches. So that gives you an idea of the type of problems you'll be working with in class tomorrow. For the second day of this, we'll just look at some more complex problems.